Hello students, welcome you all. In NMR Spectroscopy, today I will discuss about the precession and Larmor frequency. In my previous lecture, I told you about the nuclear spin and nuclear spin states. So what I told you that the nuclei of an atom is spinning on its own axis like that of electron. And if they are spinning, then they will act as a tiny magnet and will have certain direction of magnetic field, and the direction of magnetic field that we can determine by right hand thumb rule. So what I told, the nuclei is spinning on its own axis, but in presence of external magnetic field there is one more rotation, and that is called as the precession. So one thing, that nuclei is spinning, there is one kind of rotation. Another kind of rotation in presence of external magnetic field that a nuclei have, they have a precession also. Okay, so and precession, what is this precession? So let us discuss what is meant by this precession. So precession is rotation like that of spinning top. Okay, the precession is the rotation like that of spinning top. And what we have seen, the spinning top, first of all, it is spinning like this, the top is spinning like this. After that, after some time, the diameter of the rotation starts increasing, and the direction goes to maximum, and then the top falls down. So in this way the top rotates. In the same way the nuclei also rotates. The nuclei also rotates in the same manner like that of the spinning top. First it is when it is rotating very fast, then the diameter is small. When it is rotating slow, then diameter increases, and like this. So what is this precession? So precession is the spinning of nuclei like that of spinning top in presence of external magnetic field. So what we can write, in presence of external magnetic field, the nuclei of an atom starts to precess, or we can say starts to wobble. Wobble is the correct word. Starts to wobble. Okay, in presence of external magnetic field, the nuclei of an atom starts to wobble, called as wobble like that of spinning top, and this is called as precession. And the frequency of this precession, or frequency of this wobbling, is called as the precessional frequency or Larmor frequency. So the frequency of precession or wobbling is called as precessional frequency. Or Larmor frequency, or which is called as the Larmor frequency. Okay, so as we increase the external magnetic field, so this happens only in presence of external magnetic field. the wobbling takes place only in presence of an external magnetic field. If there is no external magnetic field, then there would be no wobbling. So as the external magnetic field increases, then wobbling will also increase. If external magnetic field is low, wobbling is low, and it is so much low that the diameter increases and increases and nuclei, then the wobbling ceases. Okay, so in presence of external magnetic field only the wobbling takes place. And as the external magnetic field, suppose if B0 is the external magnetic field, if this B0 increases, then the wobbling frequency also increases. So omega, which is called as the wobbling frequency, also increases. So suppose I denote this Larmor frequency by this omega. So if omega increases, means omega increases in presence of higher magnetic field. So one of the relation that this omega, we can say, is directly proportional to this B0, or we can write omega, this is equal to gamma B0. This is one of the important relation. Okay, and this gamma is called as the gyromagnetic ratio. Gyromagnetic ratio. Gamma is called as the gyromagnetic ratio, and for a particular value of for a particular nuclei, gamma is having the particular value. For example, gamma for proton, this is equal to 267.53. This is the gamma for proton, gyromagnetic ratio for proton. Okay, and this is in the unit is radian per second per Tesla. And suppose if we have the external magnetic field applied is, suppose this external magnetic field applied is 1.41 Tesla. Then if we will calculate the value of the omega here, then we can also convert this radian per second per Tesla into megahertz. This radian per second, that can be converted into megahertz. And if you want to convert it, then we should divide this value by 2 pi. So 2 pi, and this is in terms of megahertz per Tesla. And suppose if we multiply it, then we will get this value. We will get this value in terms of megahertz per Tesla. Now, so omega for this proton, if we are studying the NMR of this proton NMR, then this omega value, this will come out to be 267.53 divided by 2 multiplied by 3.14 is the value of pi, multiplied by 1.41 Tesla. So this comes out to be 60 megahertz. So if we apply a external magnetic field of 1.41 Tesla, then this frequency that is the Larmor frequency, means the frequency by which the nuclei will precess or wobble, that would be 60 megahertz. By this value it will wobble. So this is called as the Larmor frequency or the precessional frequency. Now, so how we can show it like this? Suppose if we have this external magnetic field, this is the external magnetic field, then it can precess like this. If we have a spinning top, suppose if we have a spinning top, and this I may draw the spinning top something like this. So it starts to wobble in presence of external magnetic field. Suppose this is B0 is the external magnetic field, and this is our spinning top, and in presence of a spinning top it will starts wobbling like this, and this is the direction of a spinning top, and it will starts to wobble so such that this is the diameter of this wobbling or precessional orbit. This is called the precessional orbit. So, or the frequency by which this spinning top is spinning or wobbling is called as the precessional frequency. So this is the precessional orbit, and frequency by which this is wobbling, that would be the precessional frequency omega. So in this way, or we may draw it like this, and this is the orbit like this. Okay, so we may show it also for the, suppose if we have a nuclei, suppose we have a proton, if we want to show it for the proton, and suppose I may show it like this. So this is suppose a proton, sorry for this nuclei, and if this nuclei also spins in the same way, the nuclei also spin. That is precessing. This is also precessional motion for this nuclei. This is the precessional motion for this nuclei, and this is the direction, external magnetic field direction, and here this is the direction of precession. Okay, now suppose in presence of external magnetic field, the nuclei is precession like this, and a radio frequency, that is radio frequency, it falls over this, and the frequency, the frequency of this radio frequency, it is the radio frequency, and in presence of this radio frequency, which is called as the operating frequency of an instrument, this is also called as the operating frequency of this instrument. And when the operating frequency of this instrument, become equal to the frequency of this precessional frequency of this nuclei, then what will happen? The resonance will take place. So what I am telling you, when the frequency of this radio frequency radiation become equal to the precessional frequency, then the absorption of radiation will take place, and after absorption, this nuclei undergo flipping. So when radio frequency is absorbed, suppose radio frequency is absorbed, then flipping takes place. Flipping of nuclei will take place. Okay, so means this precession will take place in a opposite direction now. So now it can precess like this in opposite direction. So if we have this nuclei, and it will start flipping. So this is the external magnetic field, and now it will start precessing in opposite direction, as you can see. Now this is the direction of the nuclei now, and it starts. Okay, so first means here this is the direction of the magnetic field of the precessional nuclei. Okay, and this is the direction of rotation. This is the direction of rotation like this. This is the direction of rotation in this direction. Okay, so okay. So this means if this is the magnetic field direction, then it is rotating in this direction. So I should rotate it like this. This is the direction of rotation. Now, so it has now flipped. So now this is the direction of rotation. This is the direction of magnetic field, and it will now the nuclei will rotate in this direction, and this is the direction of magnetic field. So the flipping takes place when the radio frequency is absorbed. Until and unless the radio frequency or radiation is absorbed, then only the flipping will takes place. And when the flipping takes place, the resonance will takes place, and we get the NMR signal. So we can also show it by the different diagram. So let us see. Now suppose if we have a nuclei in presence of external magnetic field. So this is external magnetic field, north and south, and in presence of external magnetic field, what I told you, the nuclei will have certain direction, fixed direction. So if this is our nuclei and it is aligned in the direction of magnetic field, this is north, this is south. Here the nuclei is aligned in the direction of magnetic field, means the direction of magnetic field of this rotating nuclei is this. If this is the direction of magnetic field of rotating nuclei, it means the direction of spin is, this is the direction of spin. Okay, now if this is now at this position, suppose the radio frequency is absorbed. Suppose if radio frequency is absorbed, suppose radio frequency falls over it, or this is which is called as the operating frequency. So if this radio frequency falls over the nuclei, and if this frequency is absorbed, then what will happen when it will absorb? And as soon as it is absorbed, then the nuclei will start precessing. So it will now start precessing. So this is north, this is south. Now the direction of magnetic field, this is the direction of magnetic field, and now it is rotating in this way. So it is it has, now you can see it has a certain precessional orbit. It has certain precessional orbit like this. Okay. So when this radio frequency is absorbed, as soon as it starts precessing, and this after absorption, what will happen? Flipping will take place. Flipping occurs. So initially the direction was this, and after that the direction, this time it is, the nuclei is in the direction of magnetic field. The nuclei is aligned. In the direction of magnetic field. Having value plus half, which is called as the alpha state. Okay, once the flipping occurs, the direction changes. If flipping occurs, then this direction changes. Like this. Now as you can see, the direction of this magnetic field changes. Now the nuclei is against the magnetic field. Now you can see this is the direction of magnetic field, and this my palm is the direction of rotation of the nuclei. So the direction of rotation of nuclei, this would be the direction of rotation of nuclei, and this is your precessional orbit. This is the precessional orbit. So here the nuclei is against the magnetic field. So when this flipping occurs, then in that case resonance takes place, and when resonance takes place we get the NMR signal. So overall, what is the basic principle here? What is the basic principle? One thing is clear, that the NMR signal we will get the NMR signal only when there is a absorption of radio frequency. After absorption of radio frequency, flipping takes place and the resonance will occur, and then only we will get the NMR signal. So when the frequency of radiation or radio frequency become equal to the frequency of precessional frequency, and we should write become equal to the precessional frequency of nuclei, then only the resonance takes place, and when resonance takes place, it means the NMR signal appears. Okay, so this is the basic principle. This is the basic principle of this NMR spectroscopy. Or otherwise, what we may understand in a different way, that this radio frequency, this is the oscillating radio frequency actually. So if this is oscillating one, then it is charged one. So it will have certain electric field. So the electric field component, it will have certain electric field component. So electric field component of this radio frequency wave, when it will couple with the electric field component of the precessional nuclei, then only the resonance will take place. What I am telling you, when the electric field component of this radio frequency radiation, when it couples with the electric field component of the precessional nuclei, then only the resonance takes place. When these two electric fields couple with each other, then resonance takes place, and then the NMR signals will appear. So when resonance takes place, there is a transition will occur from one state to the another state, and we will get the NMR signal. So this is about this Precession and Larmor frequency. Thank you.